When you think of a lake, what comes to mind? What comes to mind? Probably one big single body of water, right? Sure, the currents flow, the temperature shifts, but it's all one system. Well, it turns out some of the most fascinating and frankly dangerous lakes on Earth completely break that rule. So, what if, deep beneath a totally calm surface, there was another ancient body of water, one that's been completely isolated from our world for thousands of years? Well, let's dive right in, because that's exactly what's happening in some very, very rare places. Okay, here's the basic breakdown. On the left, you've got your typical holomictic lake. That's almost every lake you've ever seen. The water mixes top to bottom at least once a year, circulating all the nutrients and oxygen. But on the right, that's where things get really interesting. These are the meromictic lakes. Their waters are permanently layered. That deep water is completely cut off, and it's often anoxic, meaning it has zero oxygen. So that's the official term for it, meromictic, and it describes a state of permanent layering. We're not talking about a temporary thing that happens in the summer. We're talking about deep water that has not seen the surface, has not mixed with the layers above it for an incredibly long time. We're talking centuries, even millennia.
So you have to ask, how is this even possible? What force is powerful enough to stop a massive body of water from doing what it naturally wants to do, which is mix?
And the answer is actually beautifully simple: density. The bottom layer is just so much denser than the top layer, usually because it's way saltier, that the two physically cannot mix. Think of it like trying to mix oil and water, but on a massive geological scale.
Now, this permanent layering isn't just some weird scientific curiosity, oh no. In some cases, it can create a geophysical time bomb, turning a beautiful, serene lake into one of the most dangerous places on the entire planet.
This number, 1,700. That's how many people died in a single night back in 1986 near Lake Nyos in Cameroon. They weren't drowned, they weren't caught in a flood, they were suffocated by a completely invisible cloud of gas that erupted from the lake itself. This absolute tragedy is what spurred scientists into action, leading to monitoring and degassing efforts to try and make sure it never, ever happens again. So this is how that terrifying event, called a limnic eruption, actually works. For years, carbon dioxide from a volcanic vent was seeping into the lake's bottom layer. And because that layer never mixes, the gas just built up and up and up, trapped under the immense pressure of all the water above it. Then something triggered it, probably a landslide. It forced some of that deep, gas-filled water to rise. As the pressure dropped, boom, all that dissolved CO2 exploded out of the water all at once.
The absolute best way to picture this is shaking a can of soda and popping the top. It's a massive, violent release of gas. Except here, the gas was a silent, invisible cloud of CO2. And because it's heavier than air, it just flowed down the nearby valleys, pushing all of the breathable oxygen out of the way.
And this really puts the potential threat into perspective. As horrifying as Lake Nyos was, its neighbor, Lake Kivu, is an even bigger concern. It's trapping not just CO2, but also flammable methane. The volume of gas is thousands of times larger than what Nyos had, and there are millions of people living right on its shores. Now, that immense risk has also created a really unique opportunity. Engineers are now carefully extracting that methane to generate electricity, which is simultaneously powering the region and reducing the danger of an eruption.
But for all their potential danger, these layered lakes are also absolute scientific treasures. Because they don't mix, their deep layers become these perfectly preserved time capsules, giving us a window into worlds we could never, ever see otherwise. Just take the Black Sea. It's the world's largest anoxic basin. The surface is a world we'd recognize: low salinity water, fisheries, tourism. But go down about 115 meters, and it's like you've landed on another planet. It's a dense, salty, oxygen-free layer that's rich in toxic hydrogen sulfide, where the only life is microbial. These two worlds are completely separated by density. And in this deep, dark, oxygen-free world, you find the most incredible things. See, organic material doesn't decay normally down there. Scientists have found wooden shipwrecks thousands of years old, just sitting perfectly intact on the seafloor. The sediment layers are pristine, giving us a year-by-year record of ancient climate. It's basically a living model of what Earth's oceans were like billions of years ago before life filled them with oxygen.
And the science gets even wilder when we go to Antarctica. The meromictic lakes in the McMurdo Dry Valleys, like Lake Bonny, are incredible analogs for finding life on other worlds. They have a permanent ice cover, just like the icy shell of Jupiter's moon Europa. Beneath that ice, they have an oxygen-free, salty liquid layer, just like the subsurface ocean we think is on Europa. And in that isolated layer, they host unique microbial life.
And listen, this isn't me exaggerating. Scientists literally call these lakes among Earth's most scientifically valuable analogs for extraterrestrial environments. By studying how life survives in these extreme, isolated, oxygen-free places here on Earth, we can get a much better idea of where and how to look for life elsewhere in our solar system.
Speaking of Antarctica, get ready for a number that's going to break your brain. In another one of these lakes, Lake Vanda, the deep water temperature can reach 25 degrees Celsius. That's 77 degrees Fahrenheit. Yeah, you heard that right. Let that sink in. A comfortable room temperature at the bottom of a lake in the single coldest place on Earth. How is that even possible? Well, here's how it works. The lake's super thick, clear ice acts just like the glass in a greenhouse. Sunlight gets through the ice and it heats up that deep, dense, salty water. But because that bottom layer can't mix with the layers above it, the heat has nowhere to go. It just gets trapped. So over centuries, it just builds and builds and builds, creating this bizarrely warm spot in the middle of the Antarctic. So we've seen that these lakes can be incredibly dangerous, and they can be priceless natural laboratories. Let's pull it all together and really look at the bigger picture of why these unique environments are so important. When you boil it all down, these lakes are so much more than just weird oddities. They are windows into our planet's ancient, oxygen-free past. They show us the absolute limits of where life can exist. They're a stark reminder of rare but catastrophic natural hazards. And because their balance is so fine-tuned, they are also incredibly sensitive indicators of shifts in our global climate. And it's all hanging by this incredibly delicate thread. A change in rainfall, a tiny increase in temperature, a geological tremor, any of these things could disrupt the density balance that has held steady for millennia, and the consequences could be dramatic. They really show us just how complex and dynamic our planet's systems truly are. Which leaves us with a final thought, right? These incredible, isolated worlds were hiding in plain sight, just beneath the surface of what looked like a perfectly ordinary lake. It really makes you wonder, what other secrets, what other hidden worlds are just waiting to be discovered right beneath the surface of the things we think we already know?